Example 3b, we're going to determine the inverse of f of x equals x squared minus 4. So we're going to let f of x equals y. So y equals x squared minus 4, and then we're going to switch x and y. So we're going to write it as x equals y squared minus 4. Now we want to get y by itself, so we're isolating y. We're going to move that over, so y squared would equal to x plus 4, and now you need to square root both sides. So when you square root this, remember it should be plus or minus the square root of x plus 4. So right now that might not be that familiar to you with that graph, but we're going to talk about that a little bit more after we use our strategy that we do know of sketching f of x and its inverses, okay? So if I sketch f of x, y equals x squared minus 4 is a parabola shifted down 4. So over 1 up 1, over 2 up 4, over 3 up 9. And I have my graph of f of x. We're going to label that f of x. Okay, switching, I'm going to graph the inverse, and then the inverse would be taking these points and switching x and y. So my strategy that I'm going to use now is to take this point 0, negative 4 and just switch that to negative 4, 0. If this parabola opens up, I know it's going to open to the right now. So you know what? I can even turn my paper sideways and sketch that graph. Over 1 up 1, over 2 up 4. Of course, you don't have to turn your paper sideways. You can just visualize those distances too. But we graph parabolas so often that this is probably the fastest, most comfortable way you can do that. So there we have it. Now, this fails the vertical line test, or the parabola itself failed the horizontal. So we can't call this f negative 1x. We have to call this the inverse. So we cannot change this to f negative 1x. This has to stay as a y. Now, how does this relate to this graph? Well, I'm just going to do a little note here. If you were to sketch the square root of x, and what would happen is if you square rooted, you would have to choose only positive x values. So if you square root 0, you get 0. If you square root 1, square root of 1 is 1. Square root of 2 is root 2, whatever. Let's pick two perfect squares. Square root of 4 is 2. This is the shape of a radical graph, or a square root of x. So what's happened here is this plus 4 made it shift left 4. So it's this general shape here now, and that's why this vertex is actually this. The reason it's plus or minus, of course, is because we square rooted it, but graphically, it also includes the reflection. So it's this part and it's the reflected part. So this is actually how this inverse graph came about. If I wanted to sketch the inverse and have the inverse be a function, and this is very important here, so this is an important part of this question still. So for the inverse to be a function, you need to restrict the domain. So you need to restrict the domain. All right, so if that means I would draw half the parabola. So if I was looking at my f of x equals x squared minus 4, then that would mean if it was the right-hand side, this would be what's greater than 0. X would be greater than 0. Then that would correspond to f negative 1x. And that would be the top half. So this would be the root of x plus 4 plus the positive part. It's not the reflected part. In other words, it would be this part here down 4. This would be f of x. And this would be your f negative 1x graph. If you were, now there's two ways you could do it. If you would have looked at the left-hand side, would have been then less than 0. So you're doing the sketching the graph that is on the left-hand side of x equals 0, so less than 0. Then your inverse function, again, proper notation with f negative 1x, would be the negative reflected part, this bottom half of this parabola right here. So again, if you were doing the left-hand side and you were sketching this, f negative 1x, I should really restrict the domain on both of these. So this one was when x is greater than 0. This is when x is less than 0. Then your inverse is the bottom half of the parabola. So this left side corresponds to this, and these would be the corresponding equations to match them.